Hey everybody, this is the third video for the Physics 1 course. It's on problem 5.6, another problem suggested by the course director who writes exams. This is the famous wrecking ball problem, also found in many different books, and it deals with a mass M being held together by a rope B with some tension TB, and another rope A with tension TA, and rope B makes an angle of theta with the y-axis. In general, it's a problem where you have several forces at different angles holding one body at equilibrium. All right. When you see this type of problem and after you draw it, you have to diagnose what type of exercise are you dealing with. Since we're dealing with equilibrium, forces acting on something, but the body still being equilibrium, being acceleration of zero, then we know that we're dealing with a sum of forces equals zero exercise. Once you realize this is the exercise that we're dealing with, you want to draw a body diagram to make sure that you'll be able to get the problem correctly. So this body will have the weight acting on it, the tension on the rope B, and the tension in the rope A. Important things to know here, you know the weight comes down and you know that the tension from the rope, they always pull, they never ever push. In other words, I will never have the tension being the other way. Okay. If the body diagram makes sense to you, then we can move to the next point. Sum of forces equals zero is a vector equation. That means that I have to write an equation for each component. For the sum of forces in the x and the sum of forces in the y. Concept, it just means that if your forces were not adding up to zero in both components, then this thing will be accelerating. All right, so let's break down the sum of forces in the x. First, I have to do a little bit of geometry and recognize that if this angle up here is theta, then this angle between tension B and the x-axis has to be 90 minus theta. So once I recognize that, I realize that the x component of TB is the magnitude of TB times cosine of 90 minus theta. TA has only a x component, which is negative, and this ends up being this following equation. I can solve for TB here and say that TB is equal to TA over cosine of 90 minus theta. And by the famous trigonometric identity, this is the same. Cosine of 90 minus theta is the same as sine of theta. All right, I still don't know TB or TA, so I have to keep going. Therefore, sum of forces in the y equals 0. TB of sine 90 minus TB times sine of 90 minus theta minus mg is equal to 0. This one I can solve for TB right away and get TB is equal to mg over cosine of theta. And that's one of my final answers. I can go back to the other equation here and solve for TA. In this case, TA would be equal to TB times sine of theta, where if I substitute the following, I will get the final answer of mg tangent of theta. And if you plug in the numbers given to you in the book, you will get that for TA, you will get about 3 times 10 to the 4 newtons. And for B, you will get 4 times 10 to the 4 newtons. This will be about 2.98 times 10 to the 4 newtons. This will be about 4.63 times 10 to the 4 newtons. All right, so let's recapitulate this problem. We'll summarize. First, we recognize it was a sum of forces equals 0 problem. Since I'm dealing with this equation, it makes things easier for me and prevents me from doing errors to do a body diagram first. When I recognize a little bit of geometry, or if this was theta, then this was 90 minus theta. Since this is a vector equation, we have to write down an equation for both the x and the y, and be able to get the x and y components, the x components of TV and TA, and the y components of TV and the weight, and set that sum equal to 0. Once you got to that point, you were done with the physics of this problem. And after that, we did the algebra, we solved for TV, and eventually for TA. Now, some evaluation you can do with your final answer is convince yourself that these equations actually make sense, the final identities make sense. So for example, if the angle theta would have been 0, meaning if the ball was being held like this, the tangent of theta will give you 0, and it will tell you that the tension on this side of the rope, the tension for this rope would have been 0, which makes sense. And that TV would have just been equal to mg, since TB will be the one holding most of the weight. All right, I hope that was helpful. See you later.